The number one mistake when buying warehouse automation: choosing a system that looks sexy on paper but is not the right fit for your specific operation. Buying automation is tough. There's a lot of esoteric terms and metrics, and if you listen to the marketing, everyone claims that their system is the best. However, anyone saying that their solution is the best for all applications is lying to you. Because in automation, there is no one-size-fits-all. Every system has its own pros and cons, and which one is best for you depends on your operation and your long-term priorities. So in today's video, we're going to be looking at the main types of automated fulfillment systems out there and how each of them compare so that you have a better understanding of what's out there in the market and what's a good fit for you. Let's start with shuttles, the oldest type of automated storage and retrieval systems. These have been around since the 90s, and essentially they consist of robotic trays on each level inside each aisle, which bring products from storage out to a lift, which then takes those products down to a conveyor and then to a picking station. The biggest advantage of shuttles is throughput. Because each level inside each aisle has a dedicated shuttle, products can be brought out of storage relatively quickly for fast picking, which makes shuttle systems good for high volume applications. Another advantage is storage density. Most shuttle systems can extend up to 60 feet in height, making them very good for facilities with very tall ceilings. Disadvantage that comes with this is cost and complexity. Shuttles are very expensive to install. They require a lot of conveyors, spare parts, complex software, engineered racking, and it usually takes a long time to set them up. We're talking about 9 to 12 months at a minimum. And of course, once you have a shuttle system in place, you're more or less stuck with it for the next 10 to 15 years, given how much work and money and effort went into setting it up. So shuttle systems can be very powerful if you have a scaled, stable operation that doesn't change much year to year and justifies the upfront cost and lead time to setting it up. The next solution we'll look at is cube storage. Cube systems store totes stacked inside of a dense grid, with robots driving on top and retrieving totes in order to bring them to a picking station. By far the biggest advantage of cube storage is density. Because totes are stored in stacks, there's very little wasted space because there are no aisles. The one caveat is that cube systems typically are limited to 20 feet in height, so the actual storage density depends on how much clear height you have in your facility. Now, to achieve such high density, you typically have to sacrifice some throughput. That's because in order to retrieve a specific tote out of storage, robots first need to take the totes that are stored above that tote before being able to access that tote through a process known as digging. And that, of course, slows down the process and takes away capacity from the robot. Now, this is highly dependent on your order profile. If you have a very steep Pareto curve, for example, 10% of your SKUs account for 90% of picks, that's not such a big deal because most of your picks are going to be coming from that top level of totes regardless. However, anything worse than an 80-20 or 70-30 Pareto distribution, and you're starting to run into throughput constraints. So cube is great if your primary motivation is maximizing storage capacity, but less so if you have a high volume throughput driven application or you're dealing with changing order volumes. Are you enjoying this video? Most content around warehouse automation is either too technical or too salesy. We're trying to make it practical, useful, and grounded in real life experiences. So if this is the kind of content you enjoy and want to see more of, subscribe to Brightpick here and follow us on LinkedIn. Back to the video. The third category is shelf-to-person AMRs. These were pioneered by Kiva Systems in the early 2000s, which Amazon then acquired in 2012 and rolled out across most of their warehouses. Essentially, these are mobile robots which bring entire shelves of products to a human workstation for picking. And the big advantage from that is flexibility. The shelves are simple to set up. The mobile robots, you just drop them into your warehouse, you build some safety fencing around them, and you're more or less ready to go. That's what makes AMRs often so attractive for brownfield existing facilities. The downside is performance. To get that flexibility, you're trading off both throughput, which is limited given the relatively low speed of the robots and the fact that they sometimes cause congestion between each other, and also density, which is also quite low because the height of the shelves is rather limited. So these shelf-to-person AMRs are very good if you're looking for an easy, low-cost way to automate, but less so if you want to extract maximum performance from your warehouse. Which leads me directly to the next category, Tote-to-person AMRs. This is the generation of AMRs after Kiva, and the main difference is that instead of storing products in these shelves, they are stored in totes, and only that one tote is brought out to a picking station. This has a few advantages. First, the shelving where the products are stored can extend higher, sometimes up to 40 feet, unlocking more storage capacity. Second, the robots transporting these totes are usually faster, speeding up picking and improving throughput. And of course, since this is an AMR-based solution as well, you retain the advantages around flexibility and ease of installation. That being said, throughput of these tote-to-person AMRs is still relatively limited and plateaus at a much lower level compared to shuttle systems or mobile manipulators. So again, it's a great solution if your primary motivation is upfront and ease of installation, as opposed to maximizing performance and long-term scalability. Now, the last category, in my opinion, is the most exciting one, and that is mobile manipulation. All the systems we've discussed so far operate on a traditional goods-to-person model. Products are retrieved from storage, brought out to fixed workstations, where either a person or a robotic arm completes the pick. Mobile manipulators change that model. Instead of simply transporting items from one place to another, these robots can pick individual items fully autonomously directly inside the storage area. This eliminates the need for the robot to constantly travel back and forth between storage and picking, and the result is shorter travel distances, less congestion, fewer handoffs, and much lower labor costs and cost per pick, as well as potentially much higher throughput that exceeds even shuttle systems. Now, mobile manipulators can be both AMR-type systems, such as Brightpick Auto Picker, where robots move freely through the warehouse, or high-density grid-based systems like Grid Picker, optimized for maximum performance and throughput. Of course, mobile manipulation is only effective when a meaningful share of a warehouse's items can be picked robotically. And even though robotic picking has improved tremendously in recent years, driven by advances in AI, computer vision, and hardware, there will still be some products, particularly those that are very bulky, heavy, or unstable, which may still require human handling. So for warehouses with the right product mix, mobile manipulation represents a fundamentally more efficient way to do fulfillment. So wrapping up, the question you should be asking yourself is not what is the best automated fulfillment system out there, it's what solution is best for my specific operation. If your main goal is maximum storage capacity, you should look at cube storage. If you want to maximize throughput and labor savings, you should be evaluating shuttle systems or mobile manipulators. If you want maximum flexibility, AMRs are best in class. The right choice depends on your order profile, SKU mix, throughput needs, labor goals, building constraints, budgets, and long-term priorities. Thank you for watching, and subscribe for more insightful content on warehouse automation.